Okay, let's go ahead and get started this morning. Thank you for everyone for coming in and spending a little bit of time with us today. This is Ted Pattison from Critical Path Training, live from Tampa, Florida. Okay, I will not torture you with my visual image as we go through this. But what our plan is today is to start preparing for the Power BI certification exam so that all of us can become certified through Microsoft with Power BI. Now, before we go ahead and get started, what I'd like to do is first of all note that there is a GitHub repository. So once again, if you go to this URL, if basically you go to github.com critical path training, what you'll find is that we have several different repositories, and this one repository, which is just Power BI certification, that is where I have posted the slides. So what you'll see here is that there's both a PDF version and a PPTX version. Note that if you just click on the PDF version, you can actually take the slides and render them, right through the GitHub site inside there. Okay, so just wanted to make sure everyone knows that these are available. And one more time, just kind of let me list out the URL here. So basically, if you go to github.com, Critical Path Training, Power BI certification, that's where you can get the slides. This is a level 1 session, and I plan to do 3 of these. So there'll be a level 2 session later this year, probably early next year. There'll be a level 3 session, and all the resources that I'm going to give to you for you to go and bulk up on your Power BI knowledge are going to live inside there. Okay, now, what is the exam that we care about? 70778. Okay, let's go back here and let's go ahead and do the non-Microsoft Bing for that particular number, which is 70 and then 778. So what we're going to see here is that there is this Power BI certification exam. Now note that the exam is still in beta. Now some of you might choose to take it while it's in beta. It's, to me, not as hard a test as it could be, so maybe the fact that it's a little bit easier and it might toughen up when it gets out of beta might be an important note. From what I've heard, there's a good chance that the released version of the exam should be out by the end of this year. If it's not out by the end of the year, it will be out very early next year. Now, if we look currently at the skills measured, once again, this is the beta skills measured. I'm about to cover this, in the slide deck right here. But I suspect as soon as the new exam comes out post-beta that they will update this particular agenda. Okay, so now you've seen that. Let's go ahead and move back to my slide deck. Now, what we're going to look at here is just kind of going through what Microsoft has listed as the skills required to prepare for exam 70778. Then we're going to break out into different categories or different topical areas in Power BI, and I'm going to go through 20 different sample questions. If you have gone to the Power BI, the Critical Path Training site and taken our pop quiz, pretty much that's the quiz that we're going to go through today. It's also the quiz that we handed out in paper form at the Microsoft Data Insight Summit. Now, another thing, if you like this and you understand everything we covered today, no rest for the weary. Starting tomorrow, we're going to publish the level 2 exam. We're not going to talk about what the answers are for a couple weeks, but the idea is that we want to keep pushing people to learn more and more about Power BI. Okay, now as far as skills measured on the beta exam, and that's as close as we can come to knowing what they'll be for the released version of the exam, Section 1, consume and transform data with Power BI. Section 2, model and visualize data. And Section 3, configure dashboards in the Power BI service. So let's just kind of take a tour through what they've listed. So the first part is really data sources and queries. So they have a connected data sources. So connected databases, understanding how to use Power BI desktop to open up a file, like a CSV file or an Excel workbook file or a JSON file. It gets to be important. The fact that with Power BI desktop you can query folders and basically find the folders and files on your local hard drive. Okay, import from Excel and connecting to other different types of databases, and particularly SQL Server analysis services, which can have tabular databases and multi-dimensional databases, is also going to be an important topic I would expect to be required knowledge for the exam. Okay, now there's perform transformations. So design and implement basic queries, know how to use the basic steps. So when you add applied steps to your query, what type of operations can you use? When they talk about applying business rules, quite often it's things like in the query, taking a company name and bouncing it to uppercase. Okay, now change the format to support visualization. So sometimes you have to do things like take city and inside your query, have city, comma, state name to remove ambiguity to support a certain type of visual, like the map visuals that utilize the underlying Bing location service. Okay, now there's also cleanse data. So knowing how to create queries that deal with common problems with data that's either unstructured or has null values or missing values or has duplicate rows, gets to be an important part as well. Now, create and optimize data models. So now we're moving on to the data modeling part. So manage data relationships, definitely going to be quizzed on that. Optimize your model for reporting. We're going to talk to that. Basically, that means design a star schema. Just because your database is normalized doesn't mean that the model you create in your Power BI desktop project has to be normalized as well. Manually enter data. So in Power BI desktop, there's a way to create a query where you just type in the values, so knowing how to do that. They have use Power Query, which seems like it's not the right thing they should have written in the agenda. We definitely want to use the query tools. We just don't call them Power Query unless we're in Excel 2010 or Excel 2013. And this exam should be all about Power BI desktop. Okay, now when we move on to some of the other things they're going to quiz us on in the data modeling section, what we can see is calculate columns, tables, or calculate columns, measures, tables. So being able to write DAX for a calculated column and a measure, being able to create a table dynamically using something like the data table function or the calendar function or the calendar auto function in DAX. Now, they have create performance KPIs. I tend to think that this is just a mistake because in Excel, in the data model, we have KPIs. In Power BI desktop, we do not. We have a KPI visual, but there's nothing I saw in the test that really kind of tested for KPI, so I think you can ignore this. But creating dimensional hierarchies within a table, gets to be a very important part. So knowing how to create the hierarchy in something like the products table where you have categories, subcategories, and products, is going to be important as well. Now, next in the data modeling section, how to create and format your visualizations. And I take this back. This should be the dashboard section. So they have a dashboard section, which I think really should be a reports and dashboard section. But understanding visualization types, configuring basic things like the report layout inside of Power BI desktop gets to be important. Okay, now let's go ahead and if I look to this last page right here, or the last part of the agenda, they ask questions about the Power BI API, and I think that there's some things that you should know about it, but some things are developer level, and I'm not exactly sure how far they'll go. In the level 2 preparation, we'll take on more of kind of the developer level things that you're going to have to know for this exam, such as what can you do with the Power BI Service API, how does Power BI Embedded work, things like that, how to create custom visuals. Okay, now as far as creating dashboards go, being able to publish a connection, being able to do things, such as, configure a dashboard. So we typically create dashboards by taking reports and basically pinning their visuals to create a tile on an existing or a new dashboard. So things like adding text inside there, pretty basic. Make sure with a dashboard you can see how you could either add a image that you have or individual shapes. They have filter dashboard, but here I think the test maker got the question wrong because we really can't filter dashboards. We can filter reports. That's one of the main differences between dashboards and reports. Okay, so what I'm going to do is let's keep moving by this section. Now that I've given you kind of an idea of what is going to be on the exam, things about publish to web, publish to SharePoint, working with row-level security? Okay, so let's go ahead and jump into some sample questions. So here's first question. Which of the following versions of the Windows operating system supports installing Power BI Desktop? Okay, note that you cannot install Power BI Desktop directly on the Macintosh iOS operating system. However, people are finding ways to have a virtual version of Windows running in a Mac and being able to then have a Mac and use Power BI Desktop. But this question specifically asks about what versions of Windows. So Windows Vista is not supported. That's probably not surprising. Windows 10 is supported. Windows 8.1 is supported. How about Windows 7? What do you think? That is indeed supported with Power BI Desktop. And Microsoft knows that there's lots of corporations that have 10 to 20,000 seats. Everyone's running Windows 7. And to basically not allow us to install Windows 7 would have been problematic for Microsoft in reaching to these large companies with Power BI Desktop. Okay. Now, let's get into specific sections. So let's go through some questions on queries and data sources. Now, remember that Power BI Desktop, the way that we use it in most projects is to import the data and create an imported data model. So Power BI Desktop becomes our extract, transform, load, or ETL tool. And the idea is Power BI Desktop can pull data back from just about any type of data source that you can imagine. Power BI Desktop also has the wherewithal to store data source credentials and to be able to seamlessly authenticate against the data source when it's going to pull data out of it inside there. Okay, now if you have Power BI Desktop, and I would say, make sure you're using the latest version, and I go to the Get Data tab inside here, and I say something such as Get Data More, it gets to be very easy for you to basically figure out, let's go ahead and wait for this screen to come up, what type of data sources. For instance, I click on File, and there are the file formats currently supported. I click on Database, I click on Azure. So by going to this dialog and just kind of reviewing all the existing data sources and figuring out, which ones are released and which ones are in beta, it gets to be a good exercise for knowing what's going to be on the exam as well. Okay, now here's another question. Which of the following items is never stored within a PBIX project file? So the data rows of tables for imported from external data sources, now that's obviously going to be part of the PBIX files. That's what makes PBIX files so big, is the fact that you've imported your data. How about the default values for query parameters? Now that's going to be fine too. That's allowed inside of a PBIX project file. Code written in R is absolutely allowed inside of PBIX project files. So there's three places we can use R, and that is when you create a query, you can use your R script as the starting input source. You can also add a piece of R code as an applied step in a query, and you can basically add R code when you use the R visual in a report. Okay, so the correct answer for this one is data source credentials. Power BI Desktop will always store your data source credentials in an external file that's specific to you and will never store them inside of a PBX project file. And the idea is if you provide your username and password to your local SQL Server database and you publish a project, Power BI Desktop will never inadvertently use your credentials so that refreshing uses your credentials instead of some other account. So after you publish a project with Power BI Desktop that has an imported data set, you're always going to have to go in the browser and configure the credentials for the data source in order to get refresh working. Okay, great. Now, knowing about writing queries and knowing how to use basic applied steps in a query to rename a column, what gets to be very common is converting column types, such as if you have any type of value that is a currency value, making sure that you convert it to a fixed decimal type. It's very common to convert date time to date so that you take off the time element. Okay, you can format column values, and in a query, formatting is different than the formatting that you would do to a column in the data model. Formatting in a query actually does an irreversible operation. So formatting in a query is when you do things like take text and bounce it to uppercase. Okay. Now you might want to replace column values. So in one of our lab exercises in Power BI Bootcamp, one of the things that we do is we have someone replace M and F values with male and female just at the query level, and you'll see that it just makes reports easier to read. So the fact that you can take any value in a column for a specific row and replace it in a very easy way, gets to be a good thing to do. Understanding how to expand related columns when you have two different columns and you want to take one side values and expand it to the records of the many side. Being able to do that. Merging columns together, which we can do either two columns in a single table or from two columns and multiple columns in two different tables, we can merge them together as well. And then also knowing how to split out columns. For instance, if you have last name, comma, first name, and you want to split that into a first name column and a last name column, knowing how to do things like that in the query tool as well. Okay, question number 3. When designing a query in Power BI Desktop to clean up data, what operation can be used to remove non-printable characters? Okay, well, we have scrub, trim, clean, and sanitize. Now, scrub and sanitize are not real operations. I made them up because that's the name we use in other tools. So trim and clean are both actual operations that you can use in a Power BI Desktop query. And clean is the one, that actually does the work of removing non-printable characters. So cleaning data will definitely be on the test. Remember that trim removes the white space, at the end and at the start and end. If I quickly kind of move back over here into Power BI Desktop, and then I bring up edit queries inside here, and I go to a particular column, and now I right click on this column and we choose transform, there is trim and clean down here. Okay, so remember that trim is used to remove the white space at the start and end of a value. Clean is what removes the non-printable characters. And so many of us just kind of in a routine sense, when we have data and we're not sure if it's clean or not, we'll run a trim, and then a clean operation. Now, let's say you have another common issue where you're bringing in the customers table and you're bringing in the invoices table and you're trying to create a relationship between customers and invoices, which means you need a unique customer ID. What if there's two rows with the same customer ID and you don't have unique values? Well, what you have to do is you have to use a group by to basically deduplicate the rows, to make sure that, any customer ID is only used one time so that when you have a unique value, you can create a relationship based on that. Okay. How about privacy levels? So Power BI embraces the notion of privacy levels so that when we have data sources, we don't inadvertently open our garage door and let our neighbors see things we don't want them to see. So we're able to mark data sources with 3 different privacy levels inside there. Now, the one that is not a real level is protected, but public, private, and organizational are basically privacy levels that you can basically set for a particular data source. Okay. Now, next thing we want to look at is that when we are writing queries, behind the scenes, we have the M programming language. So back here, let's go back to our query tool and note that with our particular query tool right here, if I go to view, I can turn the formula bar on and off, and if that's the case, I can basically see a piece of code written in a language called M behind every single step. So for instance, if I go back up here and now we just start stepping down, we're going to basically see all the M code. If I go to the View tab and I choose the Advanced Editor, I can see that every single query, is just stored as a bunch of M code inside there. Now, the thing that I would like to get across is that if you're using Power BI Desktop, there will be some people that never work with M directly. They use the Query Designer tool, and all the M code is written behind the scenes. They never have to get their hands dirty. There's another type of individual, probably you fit into this group if you're at this session, and that is if there's M code and you can touch it, You want to basically get comfortable with it. So there are definitely times where you can benefit by being able to go into the M code and make direct edits to that yourself. If you've never worked with M code, there's only one guy in the world who's really kind of seen as a expert outside of Microsoft, and that's a fellow named Chris Webb, who's got a great blog. You might follow that. But just having an idea of what M code is and when you can use it might be important for the exam as well. Okay. Now, if you don't know the M programming language, this might be a hard one. Which of the following is not a valid variable type when programming in the M language? Record, list, function, or data frame? I was trying to be tricky. Data frame is not part of M. It's the most common type we use in the R programming language when we work with Power BI Desktop, but it's not supported in M. Okay, let's get a little bit tricky. What languages can be used when designing a query in Power BI Desktop? Well, the obvious answer is M. So every single query that you ever write in Power BI Desktop has to have some M code behind it, whether you've written it or you let the tool generate it for you. However, when you write a query, you can also put a raw SQL statement as your input source. So in fact, the SQL will get embedded inside of the M code. So both of those languages are supported. Now, what if your query wasn't against a SQL database, but instead it was from a SQL Server Analysis Services database that was running either a multidimensional database or a tabular database? If you're creating a Power BI Desktop query against a multidimensional database, you can actually write MDX code and add it inside there. And if you are writing a query against a tabular database, you can actually write DAX code. So DAX code can be embedded inside the M code inside of a Power BI Desktop query. The only one which is completely not supported in any way, shape, or form in Power BI today is Python. Hopefully a couple of years down the road, we'll look at the Python support that was added in mid 2019, and we'll realize how great it was. But there's nothing that seems to make me think that Python is going to be supported in Power BI Desktop in the near future. I would love for that to change, but that's how I am reading the tea leaves currently. Okay, now another important thing to understand is how to work with Power BI Desktop project template files. Now, let's go back to this project. So let's say that I'm working on a particular project in Power BI Desktop, and note that if I do a save as, it's going to save this as a PBIX file. So another option that I can do is if I go down and for my particular project, and I can't be in the query editor, I have to be back here. If I do a save as, and then we do, one more time, let me go back to the tool, the main window, let me choose Export and Power BI Project Template. So the idea of a Power BI template file is that you have a database that's the same across 10 different customers. And you don't want to have to go and create the exact same Power BI Desktop project for all the different customers, because they have different SQL databases, but the SQL database table schema is the same across. So the idea is if you create a project and you're able to create all the queries and the data model and the report, but what you really don't want is you don't want the rows of data from the dev database that you were using. So the idea of the Power BI template file is it keeps everything except for the rows of data. And so you might have a PBIX file that's 10 megabytes in size, and then when you create the PBIX file, it might be down to 1/100th that size because there's no rows of data. And the idea is once you open up the template file, it creates a regular Power BI desktop. You add query parameters so you can start parameterizing away things like the data source connection string to that SQL Server database. And the idea is when you bring up the new project, it asks you for those query parameters, you put them in, and it then populates the project with data inside there. Okay, so just knowing the basics of what template files are all about gets to be important. That leads me to this question. Which of the following can be saved inside of a PBIX project file but is never saved inside a PBIT project template file? Okay. So data source credentials is not the right answer because that can't be saved in either PBIX or PBIT files. Query parameters can be saved in PBIT files, and they're very important. The default value for query parameters can also be saved. So the correct answer is the rows of data are never saved inside of a project template file. Okay, so that basically takes us through our first section, where we're talking about queries and data sources. Okay, let's go ahead and move on to working with data modeling and the DAX evaluation language. Now, when we start working with Power BI Desktop and we're starting to import data, you're really starting to create a data model. So some of the things that we think about is model our imported tables using a star schema. We're going to create relationships between the tables. We're going to modify the columns inside of our tables. We're going to go ahead and create calculated columns and measures. We're going to create dimensional hierarchies. And quite often we're going to add some type of a calendar or date table inside there so we can make sure that our time intelligence functions in DAX work properly. Now, the idea of the star schema got to be a very big thing over the last 10 or 20 years when we start working with databases that are read-only and are geared towards data analysis and reporting. So quite often we start by pulling data from a database, which we kind of consider a OLTP, online transaction processing database. And so quite often the tables are normalized, which means we have lots of tables, we have lots of joins that we have to run. And the idea is that when someone creates a transactional database, they have to worry about inserts and updates running very quickly. And they have to make sure that no data is duplicated. Any piece of data only lives in one particular place. Okay, but what we'll see is that if you just take a transactional database and import the tables as is, it's not going to be very good for reporting. So quite often we do what's called denormalizing the data. It's okay if things are duplicated because it's read-only data. We don't have to worry about inserts and updates because it's read-only data. And so by following something where all the tables are categorized as either fact tables or dimension tables, and the idea of fact tables is that they're the really long tables that often just have numeric-based columns. And the dimension tables are going to be much smaller, and they have a lot more string-based data. And they basically give us the dimensions in which we want to break down and drill down into our data. Okay, so just kind of understanding what a star schema is and why we typically design the tables in our data model around the star schema gets to be important. Okay, now a little bit more about relationships in Power BI. So remember, Power BI Desktop is built on the tabular database model, as is Power Pivot in Excel, and as is the tabular database model when you create tabular databases for SQL Server analysis services with Visual Studio. And so relationships are really defined by the tabular model. So Power BI Desktop just follows the rules that Power Pivot in Excel and SQL Server analysis services follow when it comes to how table relationships work. So when designing a data model in Power BI Desktop, which of the following statements are true regarding the rules for creating table relationships? A relationship between two tables can be defined using multiple fields from each table. That is false. A relationship must be defined by a single field from each table. Okay, next question. At least one column defined in a table relationship must contain unique values. That is true. Both can contain unique values, but at least one of them has to contain unique values so that you can have a one-to-one or a one-to-many relationship. Okay. A relationship between two tables must be defined using a single field from each table. That is also true. You can find multiple relationships between two tables in the data model, but only one of them can be marked as active. And that is also true. So there's this idea that if you have a date table and you are trying to mark it to the orders table, but in the orders table you don't just have one date column, you have two. You have ship date and order date. The idea is that you can't create a relationship between the order date and the date table, and also the ship date and the date table, and have them both be active. But the idea is that you can create two relationships. One is going to be marked inactive, and when you look at it in Power BI Desktop, for instance, if we go back here into Power BI Desktop, and now we go down and we kind of take a look, at the relationship, of a particular calendar table right here, what you're going to see is that you can only have one relationship between them. Now, had I had another field inside here, I can create a second relationship, and what we see, let me just double click on this right here, and if I make a relationship inactive, what you're first of all going to see is when I click off it, it is a dotted line, not a solid line. That means it won't have any effect on a query when you basically run it with a DAX expression. So only one relationship can be marked as active. However, what you can do is you can have two relationships. Only one can be marked as active. And so to use a relationship that you define that's inactive, in DAX there is a use relationship function that basically says don't use the active one, but use the inactive one. Now, what gets to be a far more common practice would be to create two date tables. And there are several questions on the beta exam that kind of fixate on this one issue, and that is you have a table with order date and ship date, and what is the best way to address that? And the idea is that you have one calendar table for ship date and one calendar table for order date. Not the only way, but the most straightforward, and what I would think is the general consensus on the best way to approach that for the common scenario. Okay, let's go ahead and move back here. Now, next thing we looked at is relationships, and the idea is that in the tabular model, you can only have one relationship that's active between two tables, and it has to be based on a single column, and there has to be unique values in a column that is on the one side of a one-to-many relationship. Now, another thing to note is that there is an important thing which is called the cross-filter direction. The idea of the cross-filter direction is that the filter will automatically propagate when you go from the many side to the one side. However, what doesn't happen is going the other way. So by configuring a relationship to cross-filter in both directions, gets to be a common thing that we need to be able to do. Okay, now just to kind of show a simple example inside here. Let's say that we have sales and we have purchases inside here, and what we can see so far is that we have a relationship with customers and sales. Let's say I go back here and I kind of put that to both directions. Okay. And then we come back up here and we set this to both directions. Okay. Now let's go ahead and I'm going to go into the report. Let's create a new report. And so let's go take something from customers, such as we can take the sales region. Okay, and then I have a simple sales revenue figure inside here. Let me go ahead and make this thing a little bigger here so that you can see that. Okay, so now that we have this inside here, what I want to do is I want to go ahead and have a function or a measure inside purchases, and let's say it's called purchase count. And this is simply counting the rows from the purchase table inside here. Okay, so now let's go back here and add purchase count inside. And now that kind of looks great. Okay, now let's go back to the relationship. And let's say that when we go from the one to many side, the relationship pushes here. But let's say that as we push from the many side to the one side into purchases, and let me put this down, let's go ahead and change this and have this be in a single direction. So now we're basically not cross-filtering, as we go from sales back to purchases. I go back here, you see the problem? And that is, it's just giving me the total purchase count because it's not filtering that measure. So the idea with the cross-filter direction inside here is that if I go ahead and I set this, to filter in both directions, it automatically will filter when you go from the one side to the many side, but now when we come from the many side back to the one side, you have to set that in both directions, and then all of a sudden the count starts working properly inside there. Okay, so once again, having a basic understanding, of what is meant by cross-filter direction, gets to be an important part of understanding how things work. I also wanted to point out that there is a great function in DAX, which is called the related function, that understands relationships. So related is kind of like VLOOKUP that you might have used in Excel, except because Excel doesn't understand table relationships, with VLOOKUP, you basically had to add extra parameters, to associate a primary key with a foreign key. With the related function, what's really neat is that the relationships are understood. So when you're on the many side, such as in our case, if we are inside of the customers table and we have a sales regions table and we have a one-to-many relationship for every sales region, there are many states, we can use the related function to easily pull one of the one-side items into the many-side table as a column using a simple calculated column. Okay, now let's get a little bit further into DAX. When writing the DAX expression for a calculated column, so we want to talk about calculated columns and measures. So in this question, we're talking about calculated columns. Can you assume your DAX code automatically has row context for the table in which the calculated column is defined? And the answer is true, absolutely. Okay, now let's ask the same question about measures. When writing the DAX expression for a measure, you can assume your DAX code automatically has row context for the table in which the measure is defined. And for measures, that is false. So with calculated columns, remember that they are evaluated initially when the data model loads into memory. And the idea is that the tabular database engine just goes through a table row by row, and for every calculated column, it evaluates that, and the evaluation is able to see all the other columns in the current row. So once again, calculated columns automatically have row context by default, and you can just start referencing other columns inside there. Now also remember that calculated columns are defined inside the scope of a table. Okay, now when we look at measures, measures are not evaluated at load time. They're evaluated at runtime, when someone opens a report or dashboard or when someone clicks on a slicer. So measures are very different. They're commonly used for aggregations. The other important thing to note is that measures, while you need to add them to a table, are really scoped at the project level. Okay, so remember, calculated columns live in a table. Measures really don't live in any table, and therefore they have no row context by default. You can get row context in a measure by adding one of the iterator functions like SUMX, but there is no default row context in a measure when you start writing your DAX code. Now, let's go through a couple questions about what we just talked about. Okay, which of the following statements is false? When referencing a calculated column in a DAX expression, you must include the table name. That's true. So column names are scoped within a table. So the name is OS table name, and then within the square brackets, the column name. Next one, when referencing a measure in a DAX expression, you must include the table name. And that's actually the false one inside here. So when you reference a measure, you have the option of including the table name or leaving it out. But if you believe in our data modeling gods from Italy, Marco Russo and Alberto Ferrari, and certainly I am strong believers of their faith, they have the recommendation that when you write a measure, you should not include the table name. When you write a calculated column, you have to include the table name. Then just by looking at your code and seeing if something has a table name in front of it, you can distinguish whether it is a calculated column or a measure. Good stuff. Okay, next question. Which of the following statements are true about modeling in a Power BI desktop project? Okay, within a Power BI desktop project, all dimensional hierarchy names must be unique. That is false. Dimensional hierarchies, like calculated columns, live within a table. So if you have two different tables, they can both have a dimensional hierarchy that has the same name. Okay, within a Power BI desktop project, all measure names must be unique. That is true. So remember, for scoping purposes, measures live at the project level. So you can have two measures in a project of the same name, even if you think you've put them in two different tables. Within a Power BI desktop project, all calculated column names must be unique. And just like dimensional hierarchies, they live within a table. So you could have two calculated columns of the same name in a project as long as they lived in different tables. Last question, within a Power BI desktop project, all query parameter names have to be unique, and that's true as well because they are defined at project scope. Okay, so what we've seen is working with DAX gets to be important. You know, all the reading that you could do from the Marco Russo and Alberto Ferrari books, they have their definitive guide to DAX, and then they have a nice new book, which is not on DAX, but analyzing data with Microsoft Power BI and Power Pivot, kind of the data modeling book. You know, I highly recommend both of those books to people that want to get up to speed and really, you know, feel very comfortable about the different data modeling and DAX authoring chores that you have. Okay. Now, when we look at the DAX language, there's all kinds of functions for date and time, information, logical functions, statistical functions. You know, so I definitely would go through a reference, you know, just to remember, you know, what functions are there. Okay, now, here's a couple of example questions. Which of the following does not return a table? The calculate function, the values function, the all except, or the filter? And it turns out that the one that does not return a table is calculate. It returns a scalar value. Calculate is the heart and soul of intermediate to advanced DAX. So definitely you need to take time and get very comfortable with what the calculate function does and common examples of how we use it. Okay, this one's a little bit tricky. Which of the following DAX expressions are valid and can be used for table filters when configuring row level security? Now, I try to be cutesy here and have the OR as or versus and the state Oregon together. So hopefully that wasn't too confusing. But what you'll see is that OR in DAX is not an operator, it is a function. So the first one uses OR as an operator, which does not work in DAX. And it turns out that OR as a function, number two, you know, is legitimate. So we have OR, state equals Washington, comma, and then we have an OR function nested inside of an OR function, so I can have three different things inside there. Now, the OR operator that we should use in DAX is the double pipe. And I think what you'll see here is if you need to say the state equals Washington, Oregon, and California, you know, using the double pipe is a lot easier because you can put a third, a fourth, and a fifth, and you don't have to start nesting OR functions inside there. Now, what we got a little less than a year ago was the in operator. So you say state in, and that's actually a really easy way to write it, but unfortunately the test question writer was evil. So the last one is wrong, not because the in operator doesn't work, but because if you use the in operator, what's going to happen is that you are not going to use the parentheses, you are going to use the curly braces instead. Okay. So state in curly brace, W-A-O-R-C-A, close curly brace, you know, would be valid. Okay, now let's move on to something else with data modeling. We have something which is data category. So if you have a column and you have some data, you know, such as a string column that has a state or a city or a zip code, we're able to take those columns and assign a data category to improve their ability to map to geographical locations when we use the built-in visuals, such as the map visual and the shape map. So which of these are valid data category settings? And it turns out that latitude, longitude is, city is one, address is one, and place is also one. You know, so all of these are valid data category settings. Now, as far as data category settings go, let's go back here. And if I now go back inside here, and so let's go ahead and look at our customers table. You know, so note that with customers inside here, what we have is we have things like state. And if I go to the modeling tab and I drop down data category, you can see what the different categories are. Okay, now one other little crazy thing right here is, let's go ahead and take city, and notice that my city is marked as a city and a state. Okay, so with that, let's go ahead and add a new map. So I'll come back here, we'll add a map. We'll go ahead and we'll add sales revenue to make the bubbles bigger. Then we will go to customer and we'll choose city inside here. Okay, and what we should see right here is that if you have city and you have city categorized as city, it doesn't work. So there were some changes that happened last June. If we go back to first quarter of 2017, this would work fine. But now, when you have something that's a city, you can have a something inside there that also indicates state. So the idea is that if you switch it from city to place, give it another second here, and what we should see is that now it's working properly. So once again, one little tricky thing is that if you have city, comma, state, you have multiple things inside there. Your data category should be set for place, not city. Okay, interesting tidbits. Okay, next exam question. Which of the following statements are true with respect to designing a Power BI desktop project in DirectQuery mode? Now, most of us design Power BI desktop projects in import mode, where you bring the data in, and then basically your project contains an imported snapshot of the data, and we have to refresh the data if the underlying data is changing. However, there is a DirectQuery mode. Remember that DirectQuery mode works against transactional SQL databases. We do not use DirectQuery mode to connect to a analysis services database, such as a multidimensional database or a tabular database. So basically, you're going to a SQL database. Now, the idea with DirectQuery is that it allows us to look at the live data. However, what we find is that there's many restrictions on what you can do with DirectQuery mode. What I've seen over the last year is that 100 people hear about DirectQuery mode and 70 get excited saying, that's something for me. And then as people learn about what the limitations of DirectQuery mode, we drop from 70% down to about 8% of the people that can actually use DirectQuery mode. So which of the following statements are true with respect to DirectQuery mode when we're designing Power BI Desktop? First one, you cannot add calculated columns to the data model. You actually can add calculated columns. You weren't allowed to in the spring, but in June is when they opened that up and they started allowing us to add calculated columns to the data model of a DirectQuery mode project. Okay, all queries in the project must be based on a single data source. That is true. And remember, once you go in DirectQuery mode, you no longer can have any imported data. So it's a very restrictive model. Next question, you cannot convert column data types in a query. That is true. So anytime you want to convert column types, you basically have a SQL statement that is your data source, and in the SQL statement, you convert the data type of a column at the database level, so by the time it comes back to your Power BI Desktop project, you don't have to worry about converting it because it's already in the correct type. Okay, and then the last one, you cannot add measures. That is false. Okay, so when it comes to DirectQuery mode, just remember that all tables have to come from a single database. Many types of query steps are not allowed, including the most important one, so you cannot convert a column type in a query when you're in DirectQuery mode. No special treatment of date columns, so they don't add an automatic hierarchy. Calculated columns used to be disallowed, but have been allowed since June of 2017. And then also, you'll find that certain types of DAX, whether you write them in calculated columns or measures, will be flagged and will produce an error. Now, if I go back to Power BI Desktop, and I go to Options, Settings, and Options, and inside there we go to DirectQuery mode, note that if you use a function such as rank X and many other functions that are deemed to be expensive, that Power BI Desktop will raise an error saying you cannot use that because you're in DirectQuery mode. However, you can add this option. you can click OK, you can start down and restart Power BI Desktop, and then you can use any function in DAX, and you're basically saying, if I get a performance penalty that's really expensive, it's my fault because I basically turned off the testing in Power BI Desktop to look for inefficient DAX code in DirectQuery mode. Okay, interesting stuff. Let's go ahead and move back to our exam here. Now, a couple things we're going to look at now, reports and dashboards. So remember that there is a set of visuals that are built in, and just memorizing, what visuals those are, I think is an important thing for the test. Also remember that Power BI has a very neat capability where developers can create custom visuals and consumers can then import the custom visuals, into their projects. And the fact that Microsoft created the visual framework to be extensible by third-party developers, to me is a huge advantage that we have, over the people in Tableau who are basically reliant on the product team, to add a new visual anytime they get a new visual, in their toolbox inside there. Now, another thing to understand is the way that licensing works. So up until last June, we just had user licenses. We had the free license and we had the pro license. And so Microsoft introduced Power BI Premium in June at Microsoft Data Insight Summit. And the important thing about that is now there's no longer just user licensing, but now we have something which is called capacity licensing as well. So the idea of buying Power BI Premium means that you're buying a chunk of hardware, or what's called a capacity, and that you're able to run your content. Basically you can take an app workspace and assign it to a capacity, and then all of a sudden all the data sets, reports, and dashboards that run in that app workspace, run with all the licensing rights of Power BI Premium. Now, let's get to a couple more questions. Now, this has to do with reporting. This question probably isn't quite in line with the last slide, but which of the following types can be added to the filled well of a slicer? Okay, so let's look at that in a different way. Let's say that we go back here and, inside of our project right here, let's say that, now what we'd like to do is we'd like to add a slicer to the page. Okay. So the idea is, what are the different things that I can drop in this field well? So for instance, if I have something like state, which is a native column, can I drop that inside there? And the idea is that if my mouse skills are a little bit better, I can drop that inside. That works just fine. Okay, what else? Well, here is age group. That is a calculated column. Can I drop that inside? And once again, the answer is yes. Now, the real thing the question is trying to get at is that if you have a measure like sales revenue, note that you cannot drop that into a slicer's field well. The idea is that slicers only accept things that are row-based and have row context. Now, let's say that I go down here into customers and I create a group. So the idea is that, let's say I go to state. And I go to state and I say, give me a new group. And so one of the things that I can do is, let's go ahead and create some state. And I'll just call this state groups inside here. And just to do the demo very quickly, let me go ahead and once we have a group inside here, we can kind of start adding different things inside, and that is our different groups. But the idea is, behind the scenes, that is creating a calculated column. And the idea is that you'd be able to take this and you'd be able to add that, inside there as well. So the idea is that back here, which of the following field types can be added to the field well of a slicer? Groups created with a new group command can, because they're calculated columns. Calculated columns can, because they're columns. Measures can't, because they're measures. And native columns can, because they are columns. Okay. This one already has the last answer marked. Into which of the following scopes can you import a custom visual? So when it comes to importing custom visuals, note that in Power BI Desktop, I can import the custom visual, into my PBIX project file. Note that if I go back to the browser, and inside the browser, we go into either a app workspace or we go into my workspace, and now I open up a report and put it in report edit mode. So note that you also have the import either from the store or from the file. Okay, so the question is, into which of the following scopes can you import a custom visual created for Power BI? You can import it into the scope of an app workspace, into the scope of a Power BI desktop project, or into the scope of a personal workspace. The only one that doesn't make any sense is you cannot import a custom visual into the scope of a premium capacity. Okay, so just a couple more questions to finish up. So here's a couple questions on app workspaces. Which of the following advantages are associated when moving an app workspace, into a premium capacity? Now, let's take a second to go back here. And so let's say that I go down into the admin portal. In the admin portal, we have capacity settings inside here. Now, if you have Power BI embedded, you have to buy a P1 or an EM1 license inside there. Then you're going to see your capacities. If you're using Power BI embedded, which is something in Azure, you can also get capacities inside here. And the idea is that when you have one of these premium capacities or Power BI embedded premium capacity, you can then go to your individual app workspaces, and you can then take your app workspace and decide whether to put that, into a premium or not. And when you put it in premium, that's when you see the diamond. So the idea is, imagine that you have, two different workspaces inside here, and one is running inside the scope of a premium capacity, and the other is running outside of a premium capacity in what we call the shared capacity. Okay. So, what are the following advantages to moving the app workspace into a premium capacity if you have the P1 subscription? Okay, so users who have the free license can enter an app workspace for read-only access to its content. Okay, that is false. Let's see, I'm not sure why I have that last. But the idea is that you always need a Power BI Pro license to enter an app workspace. Okay, now let's get back here one by one. Dashboards within the app workspace can be shared with users who have a free license. And that's one of the main points of Power BI Premium. And that is, without Power BI Premium, you need a Power BI Pro license to share content. You also need a Power BI Pro license to consume content. So the idea of getting Power BI Premium is that we're able to take users who without it need the Pro license for $10 a month, and we want to be able to move them to the free license where there's no incremental cost for these users. And so the idea is that the two things that work best is that an app published from the app workspace can be installed and consumed by users who have a free Power BI license. That's true. And that is what happened at first. And then about a month ago, they also opened up dashboard sharing so that if your dashboard is in an app workspace in a premium capacity, as a Power BI Pro license user, you can then share it with free license users. Okay, and then the last one is reports and dashboards from the app workspace can be embedded in custom applications and served to non-licensed users, and that is true. So Power BI embedding gives us the option, to basically pay for a capacity, not pay for users, and then be able to do things like embed custom reports and custom dashboards in a custom application and serve them up to users who have no Azure Active Directory accounts and don't have Power BI licenses. So the capacity is how we pay Microsoft to reach those particular users. Okay. Now, here we are in the final question of today. Which of the following Power BI subscriptions provides the proper licensing for the user to view Power BI content through mobile apps? So if you are a pro user, well, you can publish content. You can also see content through the Power BI service. And what I mean by the Power BI service, I mean when you go to app.powerbi.com and you start using this particular portal, and I get to a particular report or dashboard and I open it up, that's going through the Power BI service. Okay. Now, this question right here is, which subscription gives you the ability to use the mobile apps? And generally, the licensing for the mobile apps and the Power BI service come together. So if you're a Power BI Pro user, you can use it. If you are a free user, you can use it. Now, the tricky part of this question is that there are Power BI Premium P1 and EM3 licenses, and you'll find that the EM3 is about half the price of the P1. And so people say, well, that's great. I want to go for the EM3 because it's cheaper. But the EM3 license is only for embedding. That means if you have users and your users can't, otherwise, see content, they cannot see that content with the Power BI service application, app.powerbi.com, or the mobile apps. You're really only getting the licensing right to be able to use custom development and to embed reports and things like SharePoint web parts. Okay, so 3 is false, and then Power BI Premium is true. So if you have a Power BI P something, P1, P2, P3, that gives you complete rights, for your licensed users, to be able to use either the browser-based app.powerbi.com or the mobile apps. And the one thing about the last one, Power BI Premium, would be, why don't you get the licensing with the Pro or free? So there is a case where you have content in an app workspace, and you want that app, to be seen by a particular user that has the free license. And that user can't automatically see it with a free license. However, once you add the app workspace into a premium capacity, all of a sudden the free user can then see the content either through the browser-based application at app.powerbi.com or through the Power BI mobile apps inside there. Okay. So I have something that says, can you please repeat the book name earlier on? So let me go ahead and what I want to do here is let me go to the company that's taking over the world, Amazon, and we will go to books and we will look for Marco Russo. So this is the first book, Analyzing Data. So this is his new one. I think this is really good. I shouldn't say him, I should say them, because it's Alberto and Marco. This book is really short and really concise, and if you've got this book down, you will know data modeling for Power BI Desktop. The second one, which came out before, is the Definitive Guide for DAX. And in the new book, they have taken a stance on, we're not going to cover that much DAX because we did it in a different book. We want to cover the important concepts of data modeling. So once again, I'd recommend those two books wholeheartedly. Okay, so what did we look at this session? We looked at preparing for the 70-78 exam. We started to look at the different data categories: queries and data sources, data modeling and DAX, reports and dashboards, apps and app workspaces. Now, this was our level 1 preparation. Note that tomorrow, November 1st, we will be releasing our new exam, our level 2 exam, which is going to be harder. We're not going to give you the answers at first. We want to see who knows their stuff. But over the next several weeks, we'll have a similar session like this, which will kind of present the answers to the level 2 exam. Let me just also kind of finish up by mentioning that if you like this type of training and you're looking for a 4-day drill down, come to Critical Path Training, and we have a Power BI certification boot camp. We have a Power BI developer boot camp, depending on what you're looking for. I would look into these 2 different courses here. If I go back over here and we just take a quick plug and we go ahead and move over to Critical Path Training right here, and I go to our courses. For instance, here is the Power BI certification boot camp course, and if I go ahead and take a look at that, you can see that here's the day-by-day lineup, and everything that you need for the exam will definitely be covered inside of this class. So with that, I will have a follow-up email, and any of the questions that I see inside of the question pane that I did not answer, we'll go ahead and add that inside there. But I'd like to say thank you for everyone for spending time with us today with the exam review. Hopefully you like the silly Halloween branding of the slide deck. And look for more emails from us telling us about the next step in your Power BI certification. Thanks very much, everybody, for attending.